Hello, advanced algebra students, and welcome back to our next video lesson where we continue looking at special right triangles and a very particular process called rationalizing the denominators. So once again, take notes, pause the video as much as you need to, and answer the questions as they pop up. Recall from our previous video that we do have indeed two special right triangles. A 45-45-90 triangle where the two legs are going to be the identical x and x, and the hypotenuse is going to be x times the square root of 2. And in our 30-60-90 degree right triangle, the shorter side, right, this would be the short side, is labeled as x. The short leg, the longer leg, is x times the square root of 3. And the hypotenuse is 2x. Now again, even though this doesn't say that it's 30 up here, we know that it needs to be because all triangles have 180 degrees. So these pieces came from yesterday, very particular to 30-60-90s, especially that 30-60-90 and where the short side and longer side are. Now in today's lesson, we're focusing more on this process that's called rationalizing the denominator, process used to make sure that there is no square root in the denominator, because technically speaking in math, that's not an accurate answer. And so we need to do something to move it from the denominator. This is typically used with what we might call harder special right triangles, where they give us a different answer than what we can just easily work with. Now, a little bit of background, and we kind of showed this yesterday, that when we're multiplying rationals, and we're multiplying these square roots, if I have the square root of 2 times the square root of 2, it really turns into the square root of 4, because they're both underneath the square root, which then means the square root of 4 is really 2. So when we multiply it by itself, in a sense, square root of 2 times the square root of 2, we really end up with 2. And we use this process to help us when we have a square root in the denominator. Okay. Now, in order for us to rationalize and not have a square root down there, we need to multiply that bottom by the square root of 2. But if I do that to the bottom, I also need to make sure that I do that to the top. Why is that allowed? Well, really, the square root of 2 over the square root of 2 as a fraction is nothing more than 1. Square root of 2 over square root of 2, 5 over 5, 10 over 10. It's all 1. So I'm just multiplying by 1, which means I'm not changing the answer. I'm just changing the way that it looks. Square root of 2 over the square root of 2, as we just showed up here, that's really square root of 4, which means our denominator is now 2. And 6 times the square root of 2? Well, since 6 is technically a constant, it doesn't have a square root, we leave that on the outside. Square root of 2 times, there isn't any other square root, so we just kind of glue them together and say that we have 6 times the square root of 2 over 2. But if you notice, these two here can actually be simplified, right? 6 over 2 is really 3 over 1, or 3 times what's left is the square root of 2. And so that process is known as rationalizing the denominator, where we're multiplying by whatever square root it is on the bottom to the bottom and the top. So let's see what this looks like in some of our examples. This is a little bit of a harder one, where we need to find the missing side lengths x and x in a 45-45-90, where we know the hypotenuse is 8. Well, if you recall, in most of our 45-45-90s, these two sides were x, and then this side was x times the square root of 2. And in this picture, that means 8 equals that side. So we can set up an algebraic problem where 8 equals x times the square root of 2, and then go ahead and solve for x. Square root of 2 is just a number, 1.4 roughly. And so we're going to divide by the square root of 2 so that we can get x by itself. If I do that to one side, I've got to do it to the other. And we've got 8 over the square root of 2 equals x. 8 over the square root of 2 equals x. Now, we did talk about leaving square roots in the answer because it's the exact answer. However, we can't leave them in the denominator. And so we need to rationalize here, which means I'm going to have to multiply by the square root of 2 over the square root of 2, just to that left-hand side. That gives us 8 times the square root of 2. And remember, square root of 2 times square root of 2 is the square root of 4, which is 2. And can I simplify these two? You bet. 8 over 2 is 4. And we still have the square root of 2, which means that's what x is equal to. So both of these legs are going to equal 4 times the square root of 2. All because we knew this 8 had to equal the x times the square root of 2, and we're using algebra to solve. All right, here's another one. Now we've got a 30, 60, 90 where we need to find the missing side lengths, the short leg and the hypotenuse. So again, 30, 60, 90. Well, that's a horrible triangle. I can't let that one go. So let's do this a little bit better. All right, so here's 30, as the picture says. So the short leg is x, the hypotenuse is 2x, and the longer leg is x times the square root of 3. So that means the only thing that we know at the moment is that 15 is equal to that side, right? 15 is that number. So if we set that up, 15 equals x times the square root of 3. Our first step in solving, we do have to divide both sides by the square root of 3. X equals 15 over the square root of 3. Once again, we've got a square root in the denominator. We can't leave it there. So what are we going to multiply by? Well, hopefully you have quickly picked up that we're going to multiply by square root of 3 over the square root of 3, which gives us 15 times the square root of 3 on top, square root of 3 times square root of 3 on the bottom. That's square root 9, but the square root of 9 really is 3. And then we need to check and see if we can simplify. In this case, we can. 15 over 3 is really 5 square roots of 3. So x equals 5 square roots of 3. All from that lengthy process. Now if I know x is 5 times the square root of 3, we can figure out the hypotenuse because we know it's twice x, or twice this value. So 2 times 5 square roots of 3. We can multiply the coefficients. 2 times 5 is 10. Square root of 3 is going to stay underneath the radical sign because there aren't any other square roots, meaning this side would have to be 10 times the square root of 3. So a little bit of a lengthy process, but it helps us to rationalize that denominator. Last example. What happens in a 45, 45, 90 if I have this? So x, and this side is x times the square root of 2. So we should know the other leg. What's the other leg here? It's got to be the same because it's 45, 45 special triangle. So 5 square roots of 3 over here. And to find our hypotenuse, we're going to plug in that value of x right there. 5 square root of 3 times our square root of 2. Right? Plugging in 5 square roots of 2 right there. When we multiply, we can multiply the coefficients. 5 times, there's a 1 out in front of here, so that's 5. And then we can multiply anything underneath the square roots together as long as they're being multiplied. Square root of 3 times the square root of 2 is the square root of 6. And really, we can leave that because it's on the top. It is part of the numerator. So 5 square roots of 6 would be our hypotenuse in this triangle. Again, I hope you took some of the notes here and that you practiced some of these examples as we went through them. If you do have any questions, please make sure that you reach out. We do have a test coming up soon, and I want to make sure that you are best prepared for that test. Otherwise, until next time, everyone, stay safe